Today we will discuss about the binomial expansion. So before doing this part, you have to see the permutation and combination video of course. Okay. So mainly in this part we can say that this is binomial theorem for integral values of n. Of course positive integral values. So we will discuss in this video only binomial expansion for positive integral values. That means positive you can consider as a n gives the positive integral values. Okay, so we know that some a plus what about the a plus b whole square? A plus b whole square means a square plus 2ab plus b square. All of you know. And a plus b whole cube, this can be easily, you can say that a cube plus 3a square b plus 3ab square plus b cube. What about a plus b whole to the power 4? Then you have to do some calculation. And what about a plus b whole to the power 5, a plus b whole to the power 6, a plus b whole to the power 11? So in mathematically you can calculate way how to find 98 to the power 5, how to find 99 to the power cube. Okay, so in binomial, by using binomial expansion we can easily calculate in this type of sums. Okay, so now first I will discuss what about a plus b whole to the power 0. A plus b whole to the power 0, the value is 1 because we have already discussed in law of indices parts, anything to the power 0 is always 1. What about a plus b whole to the power 1? And this is also a plus b. And what about a plus b whole square? All of you know that this is a square plus 2ab plus b square. What about a plus b whole cube? So we have already done in class 7 or 8. Okay, in the formula a cube plus 3a square b plus 3ab square plus b cube. And what about a plus b whole to the power 4? So then you have to multiply a plus b and a plus b whole cube. Okay, so you whole cube, and you know you have, if you already knew this result, and after multiplication you will get a to the power 4 plus 4 a cube b plus 4 a square b square and 4 plus 6 a square b square plus 4 ab cube plus b to the power 4. Okay, after multiplication you will get this result. So the interesting part is that you see that here the indices power is 0, so you will get 1 value. If the indices power is 1, you will get 2 terms a plus b. If the indices power is 2, then you will get how many terms? 1, 2, 3. The indices power is 3, then you will get 1, 2, 3, 4 terms. When the indices power 4, you will get 5 terms. 1, 2, 3, 4, 5. If the indices is n, then you will get n plus 1 number of terms after expansion. Expansion means you multiply repeated same thing, you can multiply repeatedly, and after repetitions and after multiplication, what is the required result? So a plus b whole to the power 4, that is you multiply repeatedly 4 times, and then the required expression is this. Similarly, you can calculate what about a plus b whole to the power 5, and how many terms present there? Of course, the number of terms is, since the index is 5, so number of terms always n plus 1, that means 5 plus 1, that is 6. So you have already calculated a plus b whole to the power 4, so just you multiply a plus b and a plus b whole to the power 4. So then you will get a to the power 5 plus 5a to the power 4 b plus 10 a cube b square plus 10 a square b cube plus 5 a b to the power 4 and b to the power 5. Okay, so how many terms present here? 1, 2, 3, 4, 5, 6. So if the index is n, so we will get n plus 1 number of terms. The another interesting part, you see that here, so from in these two parts there is no observation. If you see that what about a plus b whole square, so this is starting from highest power of the index a2 and the power of a decreases by unit 1, you see that, and power of b increases by unity. The first term, the power of b is 0. That means b to the power 0 is always 1. So it can be written in this fashion: a square b to the power 0 plus 2 into ab plus b a to the power 0 b square. And you see that, so first you can consider b plus a or a plus b. So the highest indexing power first take a and the lowest indexing power is 0, so a square b to the power 0, and now the index decreases with by unity for a and index increases by unity for b. Square b to the power 0, a 2 minus 1 and 0 plus 1, 2 minus 2 that is 0 and 1 plus 1 that is b square. Okay, in this way. So this is a total observation, you can see that. Okay, so another interesting part, that this is a Pascal identity, you can say that the Pascal triangles. So you see that I have to write down the coefficient of all of this Pascal triangle. What is the due to this expression, you see this all the expression and keep it in your mind. Just I arranging some pattern by using the Pascal's triangle. Okay, Pascal is a mathematician who introduced this type of pattern. Okay, so now first you see that I erase. Okay, here I have written here in the for index part. If you indexing is 0, index part is 0, so the term is only 1. When the index 1, so the term is 1. Okay, 2 terms. So the coefficients I have written here 1, 1. Okay, so for this expansion I have write down the coefficient. Okay, for indexing 2 means this. So we will get 3 terms. So 1, 2, 1. So I have used the Pascal triangles in this fashion. That means if this 2 part is given to you and if you add these 2 expressions, you will get 2. And when indexing is 3, so for in this gap you write use the Pascal triangle, you will get this is start from O, and if you add these 2 expressions, 1 plus 2 that is 3 and 2 plus 1 that is also 3 and the last term is 1. Okay, when index 4, so similarly this is starting from 1, and if you put the Pascal's triangle in the gap between the 2 numbers and adding these 2, we will get 4, this is 6, this is 4 and this is 1 and so on. For 5, so you take this, use the Pascal's triangle here and you will get 5, this gives 10, this also gives 10, this is 5 and you will get 1. And similarly you can calculate a plus b whole to the power 6. Okay, this is a very basically using the first part for the numbers of 5, for the numbers of 4, for the numbers of cube. But you see that the coefficient, what are the coefficient here? First, when index is 0, the coefficient is 1. When the index is 1, the coefficients are 1 and 1. And when index is 2, then coefficients are 1, 2 and 1. Okay? So for 3, the index in 3, the coefficients are 1, 3, 3, 1. 1, 3, 3, 1. For index 4, the coefficients are 1, 4, 6, 4, 1. 1, 4, 6, 4, 1. Okay? So totally merged with this. Okay? So I think that it is clear to you. Okay? So next, so how to calculate a plus b whole to the power 15? I use it by Pascal's triangle? No. So we have to know the some binomial expansion theorem. Okay? I erase this part. So now, by using Pascal's triangle, I have Pascal's triangle. Expand 2x plus 3y whole to the power 4. Okay? So, whole to the power 4. By using Pascal triangles, I am indexing here. When index is 0, just I repeat it, and coefficients I have written here, coefficients. So when a plus b whole to the power 0, that means indexing 0. Okay? So that means a plus b whole to the power 0, the coefficient is 1. Indexing is 1, then coefficient is 1, 1, indexing to 1. I use the Pascal's triangle, 2, 1. When 3, use the Pascal's triangle, so this gives 3, 3, 1. When 4, I use the Pascal's triangle. Okay, so 1, 4, 6, 4, 1. Okay, so here 2x plus 3y, a and b, a equals to 2x and b equals to 3y. So if I expand this by using the Pascal triangle coefficients, so first of all 1 into 2x whole to the power 4, because the index of a will take the highest indexing, okay, 2x whole to the power 4, and 3y to the power 0. I have already mentioned this is initially start from 0 for b, and now the index of a or 2x go to decrease and index of 3y go to increase by unity. Okay, so the coefficient, what is the coefficient of the second term? The coefficient of the second term is 4. Okay, I have taken the first bracket because to identify the coefficients, and 2x whole to the power 4 minus 1 and 3y whole to the power 1. Okay, and similarly next we take this next coefficient 6 and 2x whole to the power 4 minus 2 and 3y whole to the power 2. And next 4 also, 4. So 4 coefficient is the 4, 2x whole to the power 4 minus 3 and 3y whole to the power 3. It increases by unity, and the last term is the coefficient 1 and 2x whole to the power 4 minus 4, that is 0, and 3y whole to the power 4. That is the total expansion, and we have to simplify it. So 2x whole to the power 4, that means 2 to the power 4, that is 16x to the power 4, and 3y whole to the power 0, that gives you 1. Okay, and 4, this is 2q into 3x to the power q into 1. Alright, So from here 2x whole to the power 3, so that's why I have taken 2 to the power cube and 3, so 4 into 2 to the power cube into 3 into x cube into 1 plus 6 into 2 square into x square and 3 square into y square. Because of 4 minus 2, that is 2, so 2 square into x square and 3y whole square, that is 3 square into y square, plus 4 into 2 to the power 1, 4 minus 1, 3 is 1, and 3 to the power cube and x to the power 1, y to the power cube, and 1 into this part is 2x to the power 0, that is 1, and 3 to the power 4 and y to the power 4. So after simplifying it, if you multiply all the expression, we will get 4, 8, 32, 96 x cube y plus 24 into 9, 216 x square y square and 162 xy cube plus 81 y to the power 4. Okay, y to the power 4. 16 2x whole to the power 4. Okay, so 16x to the power 4, 96 x cube y plus 216 x square y square plus 162 xy cube plus 81 whole to the power 81 y to the power 4. Okay, so we can use the Pascal triangle coefficients by Pascal identity, but we introduce the general form of the binomial expansion in terms of n, and before discussing I shall already introduced in permutation combination. I have already introduced the permutation and combination in YouTube lecture. You will see it. Okay, so first, what about the NCR? Because this NCR will play the role in binomial expansion. So the NCR means combination. This combination part, or these are the coefficients of the expansion. So what about the NCR? I have mentioned what is NCR. NCR means factorial n by factorial r into n minus r factorial. Factorial n by r factorial into n minus r factorial, where factorial n by definition factorial n equals to n into n minus 1, n minus 2, n minus 3 into 3 into 2 into 1. Okay, for example 5 factorial means 5 into 4 into 3 into 2 into 1, and of course r less than equals to n, subject to the condition. Okay, so this is NCR. So before doing the binomial expression, we have to know what about NCR. Okay, so I have written here what about NCR. So now we study the binomial theorem for positive integral values n. N is the general value. What is a plus b whole to the power n? Okay, I have written down here what is a plus b whole to the power n in the expansion. So we have already done n equals to 3, 2, 4 and also 5 and 0, 1. Okay, so what about n equals to 6 and more values? So the general form of the binomial theorem, for of course n is the positive integral values. I have mentioned we have not taken here negative n. We always take, in this video, always we take n is positive integral values. Keep it in your mind. Okay, so this is a to the power n plus, okay, I must say, I have to write down first of all nc0, a to the power n, b to the power 0, nc1, a to the power n minus 1 into b. Okay, so the index of a go to decrease and index of b increase by unity 1. Okay, so nc2 a to the power n minus 2 into b square, nc3 a to the power n minus 3 into b cube, nc4 a to the power n minus 4 into b to the power 4, and ncr a to the power n minus r b to the power r less than n, and ncn minus 1 a to the power 1 b to the power n minus 1, and ncn a to the power 0 b to the power n. This is your last term, and you see that, just observe it, a plus b whole to the power n. I repeat nc naught or nc0 into a to the power n into b to the power 0 plus nc1 a to the power n minus 1 into b plus nc2 a to the power n minus 2 into b square, nc3 a to the power n minus 3 into b cube plus nc4 a to the power n minus 4 dot b to the power 4, and after some terms I have written the r plus 1 term ncr e to the power n minus r into b to the power r, and the previous last term is ncn minus 1 into a into b to the power n minus 1 plus ncn a to the power 0 and b to the power n. If I rewrite this, okay, I have gotten nc naught a plus b whole to the power n into a to the power n, because of a to the power n b to the power 0 equals to 0, and after some calculation you will get nc naught is equals to always 1 because this is factorial n by 0 factorial into n minus 0 factorial, so you will get factorial n by factorial n, because 0 factorial is the value of 0 factorial is always 1, so this gives 1, and similarly ncn the value is also 1. Okay, so this is the trivial result. So nc1 a to the power n minus 1 into b. When anyone asks you the question what is the expansion, just you will start a to the power n plus nc1 a to the power n minus 1 plus b into nc2 a to the power n minus 2 into b square plus nc3 a to the power n minus 3 into b cube plus nc4 a to the power n minus 4 into b to the power 4 plus nc dot 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 up to some terms I have written here. The n r plus 1 term a to the power n minus r b to the power r plus nc n minus 1 a into b n minus 1, and because of a to the power 0 is 1, ncn is also 1, so we will get b to the power n. And you see that this is your first term. When nc1 appear, then this is the second term, and when nc2 appear, this is the third term. So what about this term? This is r plus 1 term. Okay, so how many terms present here? Because the index is n, we will get one more term, so that means n plus 1 number of terms. So for this expression we get n plus 1 number of terms. And what is r plus 1 term? Okay, r plus 1 term. Sometimes we are frequently asking the question, what about the in your exam anyone asking the question what is r plus 1 term? Okay, so most of the students can be written as ncr plus 1 a to the power n minus r plus 1 b to the power r plus 1. Keep it in your mind. This is a r plus 1 term can be denoted as t r plus 1. Okay, so the r plus 1th term, the expression is NCR a to the power n minus r e to the power r. If any confusion arises, then just remind a plus b whole square. How many terms? Okay, a square plus 2ab plus b square. Okay, a plus b whole cube. How many terms? 4th term. Which one the second term? Then 3 square. What is the third term? 3ab square. Okay, so tr plus 1, so that is NCR a to the power n minus r b to the power. This is the r plus 1 term because this is the first term. When NC1 appears, this is the second term. NC2 appears, third term. NC3, this is fourth term. This is fifth term. So of course this is NCR r plus 1 term. So that's why I have written r plus 1 term equals to tr plus 1, that can be denoted as and is defined as NCR a to the power n minus r b to the power r. Okay. So now we'll do some example for by using this expansion. So first just we will try solving some problems. Okay, expand. Number 1, expand. This type of questions appear in your exam. Expand x square plus 3 by x whole to the power 4 when x not equal to 0, because x is divisible into a part. So you can easily, by using the binomial expression, so x square plus 3 by x whole to the power 4. So by using the formula, this is your a, this is your b. So x square whole to the power 4 plus 4c1 n equals to 4, 4c1 x square whole cube 3 by x. In b term, the index of b increases and index of a decreases by unity, and 4c2 x square whole square 3 by x whole square, and 4c3 x square into 3 by x whole cube, 4c4, and you can write down only 3 by x whole to the power 4, the second line of the a plus b whole to the power expansion. A to the power 4, 4c1 a cube b plus 4c2 a square b square plus 4c3 a b cube plus b to the power 4. Okay, now simplify it. What 4 into 2, according to the indices rule, you can write down x to the power 8. 4c1, that is, you have to calculate 4c1. What about 4c1? Factorial 4 by 1 factorial into 4 minus 1 factorial, that gives 4 factorial by 1 factorial means 1. This is 3 factorial, and 4 factorial can be written as 4 into 3 factorial. So that was cancelled, so we will get 4. So 4x to the power 6 into 3 by x plus 4c2. What about 4c2? That is 4 factorial by 2 factorial into 4 minus 2 factorial. So after some calculation we will get 4 factorial. So we can write down 4 into 3 into 2 factorial also, and this gives 2 factorial means 2 into 1, and this is 2 factorial. 2 factorial, 2 factorial is cancelled. 2 to the 4, so we will get 6. So 6 x to the power 4 and 9 by x square. And what about 4c3? 4c3, this is also gives 4, because you see that the expression nc1 and nc(n minus 1) both are same. So 4c3 equals to factorial 4 by 3 factorial into 4 minus 3. So 4 into 3 factorial by 3 factorial into 1. So 4. So 4 into x square by 3 cube, that means 27 by x cube plus 3 to the power 4, that is 81 by x to the power 4. Okay, I think it is clear to you. So after some calculation we will get, I erase this part. So put down the value. What is x to the power 8 plus 12, x and x to the power 6 cancel, so that is we will get 4 into 3 12, x to the power 5, 6 into 9, that is 54, and x4 and x square, that is x square cancelled after cancellation, after cancellation we will get 4 7 28 4 to 8 10 108 into 1 by x square x plus 81 by x to the power 4. This is the expansion. Okay. This is the binomial expansion of this expression x square plus 3 by x whole to the power 4. So any question, if anyone asks you any expansion, you can do easily. Okay. So we will take another problem. I guess this part. Okay. Okay. Next example we will discuss about. Next example. Find a plus b whole to the power 4 minus a minus b whole to the power 4. Okay, and then evaluate. Root 3 plus root 2 whole to the power 4 minus root 3 minus root 3 whole to the power 4. Okay. So I use binomial expansion. We can write. Okay. So solution is that first we will do step by step. Then we learn about some tricks. Okay. A plus b, a minus b whole to the power 4. So by using the binomial expansion, this is a to the power 4, 4c1. Okay. Another part, I have to write down a plus b whole to the power 4 minus, I have taken a plus minus b whole to the power 4. Okay. Because we have already learned only a plus b whole to the power n. So any negative sign is appears, so you take a plus of minus something. That's you can write down this fashion. Okay. So a to the power 4 plus 4c1 a cube into b plus 4c2 a square b square plus 4c3 ab cube plus b to the power 4. I have completed the first bracket here minus this is a to the power 4 plus 4c1 a to the power cube into minus b plus 4c2 a square minus b whole square 4c3 a minus b whole cube a into plus minus b whole to the power 4. Okay. So now I simplify it. A to the power 4 plus 4c1 a cube b plus 4c2 square b square plus 4c3 a b to the power 4 plus b to the power 4 minus a to the power 4. This is the negative sign, so we will get minus minus plus. So plus 4c1 a cube b. Right or not? This gives the negative, and this negative and negative is positive. And next, this is minus b whole square, that is positive. So positive into negative, that is negative. So 4c2 a square b square. And this is minus b whole cube, that is minus b cube, and minus sign present here, and this minus after multiplication we will get plus. So plus 4c3 ab cube minus b to the power 4 minus b to the power 4. Now if a to the power 4 cancel, b to the power 4 is cancelled. Okay, and in return 4c2 and 4c2 are cancelled. So we will get 2 into 4c1 a cube b. Okay, 4c1 a cube b and 4c1 a cube b plus 4c2 ab cube. So after some calculation, what about the 4c1 and 4c ab cube, that is 4c3. Okay, force C3, and you know already, you have already seen that whatever the force C1 and force C3, both the value are same, and this gives the value 4. So you will get 2 into 4a3b plus 4ab3, and you take common part 4ab, 8ab, you will get a square plus b square, am I right? 8ab. Okay, and you can evaluate this problem by using this formula also, or you can use directly. Okay, directly expand this expression and calculate. Okay, just I have already expanded this term, so that's why I am using this result and calculate this value. So what about root 3 plus root 2 whole to the power 4 minus root 3 minus root 2 whole to the power 4. I have taken here a equals to root 3, b equals to root 2. So 8 into root 3 root 2 root 3 whole square plus root 2 whole square. So 8 into root 6, and this gives 3 plus 2, that is 40 root 6. Okay, just using the previous result, 8ab into a square plus b square. Okay, so this type of problems appear in your exam also. So I will provide you some homework. Okay, another problem, problem number 3. Just you see that. Okay, so I think another expression you must say hashtag a plus b whole to the power n. That can be already we have done a to the power n plus nc0, a to the power n minus 1 b plus nc1 plus nc2, a to the power n minus 2 into b square, nc3, a to the power n minus 3 into b cubed plus up to ncr, a to the power n minus r into b to the power r, ncn minus 1, a b to the power n minus 1, and b to the power n. Alright? Okay? I think this part you have already copied and you have understood. So what we have learned? We have learned a plus b whole to the power n equals to a to the power n nc1. This is the binomial expansion or binomial theorem for positive integral values n. So I have written here the short notation. So r equals to 0 to n ncr a to the power n minus r b to the power r. If you put the value of r, this is the summation symbol. That means you put r equals to 0, write down the first term, then put r equals to 1, then the second term, then put r equals to 2 in this expression, write down the third term, and adding all the terms, you will get all the addition that symbolized by summation. Okay, so that means this expression. Okay, put nc0 equals to 1. That's why I have not written a to the power n minus 0, that is a to the power n, b to the power 0, that is 1. That's why I have a to the power n. And then put r equals to 1 nc1 a to the power n minus 1 and b to the power 1. b to the power 1 means b. And then put r equals to 2 nc2 a to the power n minus 2 into b square. Next nc3 a to the power n minus 3 b to the power 3, and so on. Okay, so next you see that if you put this result, we put a equals to 1 and b equals to 1 in the given identity, in this identity, in equation 1 or in equation 1, or you can write down 2 also, equation 1 and 2. We will get the same expression, and symbolically you can write down. You see that this means 1 plus 1 whole to the power n, 1 to the power n, that is 1 to the power n, plus nc1 a to the power n minus 1, 1 to the power n minus 1, and 1 plus nc2 a to the power n minus 2 square, 1 to the power n minus 2, 1 square, and so on. NCR 1 to the power n minus r, 1 to the power r, NC n minus 1, 1 to the power n minus 1 to the power 1, and 1 to the power n minus 1, and then 1 to the power n. And anything 1, any index of 1 always gives 1. So you can write down here 1, you can write down here NC naught. This is NC1 plus NC2 plus NC3 up to NCR, NCn minus 1 plus NCn. This term is 2 to the power n. So what is the value of 2 to the power n? The 2 to the power n is the value NC0, NC1 plus NC2 plus NC3 plus NCR plus NCn minus 1, and you can write down here 2 to the power n equals to r equals to 0 to n NCR. Okay, you can write down also NCR, r equals to 0 to n NCR, summation of NCR, that gives 2 to the power n. Just you put down, this is also a plus b whole to the power n, and put the value a equals to 1, b equals to 1, we will get NCR 1 to the power n minus r into 1 to the power r. So summation of r 0 to n NCR equals to 2 to the power n. I think it is clear to you. So this result this is more useful in the different type of mathematics, not only binomial expansion, in physics, in any other series solution and series sequence. In this part, this expression also we will discuss on the later. Okay, so this is most powerful and useful result in mathematics. What about the value of 2 to the power n? So that is NC0 plus NC1 plus NC2 plus NC3 plus NC4 up to NCR in dot up to NCn minus 1 plus NCn. Okay, so now last problem we will do. So by using this type of result, prove that r equals to 0 to n 3 to the power r NCR equals to 4 to the power n. We have to prove it. Okay. So now this summation part. So I have taken left hand side. What is this? So r equals to 0 to n 3 to the power r NCR. So you can write down here also r equals to 0 to n. Okay, first you can write down r equals to 0 to n NCR 1 to the power n minus r 3 to the power r. Okay, you see NCR, because you see what is a plus b whole to the power n. That means NCR equals to 0 to n NCR a to the power n minus r b to the power r. You mind it? Okay, NCR a to the power n minus r b to the power r. So what about this? So NCR a to the power n minus r b to the power r, that is a plus b whole to the power n, that is 4 to the power n, and it has been put, that is right hand side. Okay, so I will provide you some examples of some exercise. You will try in your home. If any problem arises, then you can message me and comment me. Okay, so compute 98 to the power 5. Number 5, expand 1 minus 2x whole to the power 5. Expand 2 by x minus x by 2 whole to the power 5, and 2x minus 3 whole to the power 6. Find x plus 1 whole to the power 6 plus x minus 1 whole to the power 6, and hence or otherwise evaluate root 2 plus 1 whole to the power 6 plus root 2 minus 1 whole to the power 6. Okay, so you try these 4 problems in your home. Okay, you will try in your home. If any problem, so any confusion, any doubt arises, then comment me and message me. I will provide the answer. Okay, thank you.